So if you have the cosine of pi over 6, okay, the cosine of pi over 6, what you had to do is you drew a triangle, or you change it into 30 degrees, then you do a triangle, then you put 30 degrees here, and then you had to figure out this side and this side. The unit circle makes life a whole lot easier because it has what the degrees for the major angles is equal to in radians. So if I say, what's the sine of 4 pi over 3, you instantly go right here and figure it out using these two numbers. Okay? So life is a lot easier. Now, when you did this on Thursday, you drew a triangle like this and said, well, this side is square root of 3 over 2, and this side is 1/2. So cosine, and this side is 1. So cosine is adjacent over hypotenuse, which is square root of 3 over 2 over 1, which is square root of 3 over 2. Now, with this right here, what happens is x equals your cosine, y equals your sine. You do not get to write this on your unit circle, but you could go ahead and write it in your notebook. That would be a good appropriate place to write this down. Okay? So on the unit circle, x is your cosine, y is your sine. So if I asked you for the sine of 4 pi over 3, you'd instantly say that it's negative square root of 3 over 2. Boom, it's right there. That's a whole lot less work than what you were doing the other day, right? Right. So I made you do that the other day so you appreciate what's going on and how these numbers came about. But the unit circle now will save you time. So if y is sine and x is cosine, what would tangent be? Well, tangent is, if we draw this triangle again, if we're talking about this angle right here, tangent is opposite over adjacent. The opposite side is 1/2 here. The adjacent side is square root of 3 over 2. So it's this over this. It's this over this. So tangent is y over x on the unit circle. Tangent is y over x. So if you use the cofunctions, secant is 1 over x. Cosecant would thus be 1 over y. And cotangent would be x over y. So if I ask you, what is the cotangent of 11 pi over 6? What's the cotangent of 11 pi over 6? The other day you would have changed that into 330 degrees by multiplying by 180 over pi. And then you would have drawn a triangle with a 30, 60, 90 angle, and so on. But today all you have to do is look at this. 11 pi over 6 is here. I want to go x over y. So it's square root of 3 over 2 over negative 1/2. That's a complex fraction, isn't it? How do we get rid of a complex fraction? Multiply by the denominator of the denominator. So you're going to multiply top and bottom by 2. So you get the square root of 3 over negative 1, which is negative square root of 3. That's a cotangent of 11 pi over 6. Okay? Using the unit circle. Okay? Are we good with this? Okay? So, now what we're going to do today is work backwards. Okay? The other day you were finding where is the sign of like pi over 3 is equal to what? And you said the square root of 3 over 2. Now today we have the sign of what angle equals the square root of 3 over 2? and you would say that angle is pi over 3, or if they have a degree symbol, you would say 60 degrees. Because if you look at 60 degrees on your unit circle, you see its y value is the square root of 3 over 2. Now, somebody might be going, well, wait up, Mr. Bierschbach. Look at 120 degrees. 120 degrees is also square root of 3 over 2. So what answer do I put? Well, this is how we do it. Okay? This is also something you might want to put in your notes. So, this area from here to here is what we use for sine. So, when we take the inverse sine of a number, inverse sine is the opposite of sine, basically when we need to find the angle instead of the value of sine. When we're doing the inverse sine, we go from negative 90 degrees up to 90 degrees. Okay? Inverse sine is in that area. So, if we ask for one of these numbers, okay, you look at this area of the unit circle only. So, if I say the sine of x equals negative square root of 3 over 2, I look at here for negative square root of 3 over 2 for the y value, because sine is a y value, and I go, oh, right here at 300 degrees. But it's not 300 degrees. It's however far from 0 to 300 that we went. How far is it from 0 to 300? Because this is 360 degrees, right? So 360 down to 300 is 60 degrees. So I actually go a negative 60 degrees. That's the answer we want, is negative 60 degrees. Because my answer has to be somewhere in between negative 90 and 90, not 330, because 330 is bigger than 90. Okay? So it's somewhere in between negative 90 and 90 for inverse sine. For cosine, we go from here to here. So cosine, inverse cosine of x goes from 0 degrees up to 180 degrees. So inverse cosine goes from 0 degrees up to 180. So if I say the cosine of x equals negative 1/2, if the cosine of x equals negative 1/2, that means x equals the inverse cosine of negative 1/2. When you move the cosine over to the other side, it becomes the inverse cosine. The inverse cosine of negative 1/2, well, the x value where x is negative 1/2 is at right there, which is 120 degrees. Not negative 120, it's 120 degrees. Okay, so you work this part of the circle. Inverse tangent also goes from negative 90 up to 90. So it uses the same area as inverse sine. So inverse sine and inverse tangent use the same areas. Okay? So when you get down to the cofunctions, secant uses the same area as cosine. Cosecant uses the same area as sine. Cotangent uses the same area as tangent. Okay, so their cofunctions use the same areas. Okay, so with your unit circles out, let's do a few problems. All right, so we already did that one. This one is a calculator problem. So if the sine of alpha equals that, then alpha equals the inverse sine of 0.7885. And it wants it in degrees, so make sure your calculator's in degree mode. So take the inverse sine of 0.7885, and what do you get for an angle rounded to the nearest tenth? 52.0. Are we all good with that? Okay. If the tangent of x equals 1/9, or the tangent of alpha equals 1/9, then alpha equals the inverse tangent of 1/9. Do that on your calculator. About how many degrees is that? 6.34. Are we? So it'd be 6.3. Are we good with that? Okay. Now, these you can do without your calculator. You can do it on your unit circle. Where on the unit circle is the cosine equal to 1/2 at? How many degrees? Where on the unit circle is cosine 1/2? Between 0 and 180? 60 degrees. 60 degrees. The x value is 1/2. Where's the tangent equal to 1? Ooh, on this one, we have to figure out where the x value over the y value equals 1. Where the x value and the y value are the same, where the sine and the cosine are the same. At how many degrees is the sine over cosine the same? At 45 degrees. Where's the tangent 1? 45. Where is it -1? -45. Okay. Where is the sine equal to 1 at? On your unit circle. Where's the y value equal to 1? How many degrees? 90 degrees. Okay, this is calculator. We'll skip over that. So I want you to get a little bit of practice with your calculator and a little bit of practice with this, and then we'll move on and we'll do one more section today where we do a little bit more with this. But there's like 10 problems to get started with of just practicing this. It's going to take you literally probably about 10 minutes. So